In this lesson, we're going to talk about how to solve systems of equations by substitution. We're going to review that definition of systems of equation, and then we're going to review all the different methods that we've learned so far of how to solve a system of equations, and then we're going to solve by substitution. Just a reminder that systems of equations are two or more equations with the same variables. So you're not going to have an equation that's got x and y in it, and then the other equation has a and b in it. It's going to be two or more equations that have the same variables. A solution to a system is the point xy that makes both equations true. And we've talked about there are multiple ways to solve these equations. So the first ones here are great for graphing because they're already in slope-intercept form. The y-intercepts are whole numbers, so it would be easy to put it onto a graph and find the intersection. This one is great for elimination. Set up in standard form, we have numbers here that are the same, so if we subtracted these two equations from each other, these would cancel out, and we could solve it great for elimination. This one down here, we have one that sort of looks like it's in slope-intercept form, except it's solved for x instead of y. And we have one in standard form. So we have one that's solved for a variable and one that's in standard form. This is great for something else. Let's talk about what that is in just a second. So first, let's do a quick review of elimination, and I'm headed somewhere with this, so stay with me, all right? So I'm going to go ahead and solve this one by elimination. These, I see it's in standard form. I'm looking for opposites. I don't have opposites, but if I subtracted y from y, then these would cancel out. So I'm going to subtract this equation from the top equation. So 2x minus 3x is negative 1x. Those cancel out. And then negative 1 minus 6 is negative 7. So x equals positive 7. Now, what I can do is, because now I know x is 7, I can substitute that back into x to figure out what y is. With substitution method, we're really just doing this. Instead of substituting 7, we're going to be substituting an entire expression in for x in the second or in another equation. All right, so you've already been doing substitution. You are just substituting one number instead of a whole expression to figure out the other one. Here's another example of substitution. If 2 hippos equal 1 flamingo and 3 flamingos equal 1 rhino, a rhino equals how many hippos? Well, we know that 2 rhinos equal 1 flamingo. So for every flamingo down here, I have 2 rhinos. So you're substituting these 2 hippos in the place of each flamingo. So 1 rhino equals 2, 4, 6 hippos. That's substitution. Now, let's go back to that original. Actually, we're going to do something a little simpler than that original problem to begin with. So we have a system of equations. One of them is in standard form and one is in slope-intercept form. So it's not great for graphing. It's not great for elimination. It's set up perfectly for substitution because I can substitute 5 into the first equation in the place of y. So we have 6x plus 5 equals 10. And then I can just solve this equation. So 6x equals 10 minus 5, putting all the number terms on one side and all the variable terms on the other side. And then the last step is always to divide. Now, normally I would do the same thing I did with elimination, where I would substitute 5, 6 back into the original equation to solve for y. But I don't need to do that here because it already told me that y is 5. But you could if you really wanted to. Let's do one that's a little bit heftier. I think we can handle this. So again, whenever I see a system of equations, I'm going to use some analytical thinking to begin with. First of all, they're not both in slope-intercept form. I could, in theory, put this one in slope-intercept form because this one is in slope-intercept form, and then I could graph it. But just kind of looking ahead, I'm going to have a 26 divided by 3, which is going to make my y-intercept a fraction, and that's not great for graphing. I could also move this 2x over to the other side so it would be in standard form and see if it looks good for elimination, but I can tell you that it doesn't. Without doing all that other extra work, I look at it and I go, okay, this one's in standard form, 5ax plus by equals c. This one is already solved for one of the variables, so all I need to do is substitute the 2x minus 4 in the place of y in this equation. So I'm going to do a little bit of color coding here. I'm going to keep the original equation exactly the same all the way up to the y. And then I'm going to leave a little space so I can change colors. But I'm just going to put the 2x minus 4, replace the y, substitute the y with this whole thing that y is equal to. This is my elephant. This is my hippo. I can replace every elephant with the hippo. Everything else in this equation, do you see, is going to stay the same. And then in this spot right here, I'm going to put the 2x minus 4. That's the same thing as y. That's what this says, is that 2x minus 4 is the same thing as y. So in this parentheses where the y was, like in a basketball game, 2x minus 4 is subbing in for the player that's on the court. So the player that's on the court is going to go out, and then the 2x minus 4 is going to go in. And now it's an equation that's all in terms of x. So when you get to this point, stop for a second, make sure that you're achieving your goal of having all the equation in terms of the same variable. Just like when we did elimination and we added the two equations together, it was all in terms of x. It was all in terms of y. There were no x's and y mixed in. When you get done substituting, it should all be in terms of the same variable. It might be all y's or it might be all x's, but there shouldn't be a mixture. And then you're ready to solve. First you distribute. Then you combine like terms if you can. Anything that's on the same side of the equal sign. And then we move all of our number terms over to one side and all the terms that have variables in it, and we leave them where they are. So it's going to be 26. When it switches sides, it's going to switch signs. So instead of being a minus, I'm going to add 12. So I get 11x equals 38. So x equals 38 over 11. Now remember, we're trying to get x and y. So what do we need to do? Just like in elimination, what do we need to do to figure out what y is? We need to do one more substitution of 38 over 11 into one of these equations. Now, I'm solving for y. I'm trying to figure out what y is, and that equation is already solved for y. So let's use that one. You could use the top one and you'll get exactly the same answer. If you don't get the same answer, then your 38 over 11 isn't the right answer. Or you did something wrong in your solving. So I'm going to multiply 2 times 38 over 11, which is 76 over 11 minus 4. I'm using my calculator for that because I can do it in my head, but then my head might hurt. So my answer is 38 over 11 and 32 over 11. And again, you could check that by putting 38 over 11 where the x is. Do 5 times 38 over 11 plus 3 times 32 over 11 and see if you get 26. If you do, then you're right. I'll leave that check for you.